Hello, ladies and gentlemen. Welcome to this Infrastructure Made Simple series. Okay, we are here committed to provide you these hard topics, these very complex topics in a very simple manner. Okay, so before I start this session, which is about deep going into load balancers, I want to say that we have opened the membership for this channel. Okay, in this, I am going to give you n number of courses. I am going to explain each and every career journey of ServiceNow with proper demo and all. So we have started with ServiceNow admin part. So if you think you want to learn end to end with practical with demo, please join the membership in a very small amount. Okay, so also you can refer someone who is looking to get into ServiceNow from the very scratch. So this course is for you. After this, we'll go to development, then business analyst, then project manager. After that, support specialist. Along with that, there are a number of courses which I am going to make in this membership. Okay, so just stay tuned. Okay, so let's start with today's session. Let me share the image which I have created for this route. So far we have understood what a load balancer is doing. Okay, it sits in front of the multiple servers and distribute the incoming traffic so that no single server is become overloads. Okay, as simple as that. But one important question, how these load balancers are thinking or deciding which server to send the request next. Okay, so obviously this is decided by certain predefined methods, commonly known as load balancing algorithms. So there are two very famous algorithms. The very first one is round robin. So the load balancer in this round robin send request to server one by one in the sequence. Okay. The request goes to server one, then server two, then server three, and once servers are completed, again the same circle. Okay. So it is a very ideal situation, and this works well when all the servers are of same configuration, same memory, same disk. Okay, everything will be same. So this is not an ideal situation in real time. You cannot see all the servers are of same configuration. So in case uh, this is kind of theoretical. Okay, so if we have such similar configuration, then this will work well. Otherwise, we have one more algorithm, and which is known as least connection algorithm. So in this algorithm, the server see which server has the least connections and it will send the request to that one. Okay, so this is a more balanced approach. Okay, the least connection method, the load balancer check how many active connections and each server is currently handling. Based on that, it will send the request to that one. Okay, so in case of real time, this is the most favorable, this is the most suitable algorithm which is there. Okay, now let's come to one more thing, which is so now let me discuss one more thing with you, which is backend failure. Even with the smart distribution, there is a still major risk in real environment, and that is backend failure. A server environment can become slow or unresponsive due to certain other issues rather than request, like their internal issues such as hardware issue, operating system problem, or running or application issues. What these application issues are, if the application is creating n number of issues, like if the application is taking much more resources, at that time also server may feel unresponsive. Okay, server may go down. So in this case we can say, so that is why we can say that the health monitoring is very critical. Okay, even for server as well as for applications on that server. So how the load balancers are doing this health check? So what they are doing, they are sending certain probes. It means commands to servers, to applications as well. And once they receive the proper response, in that case only that particular load balancer came to know that this server is working good. Okay, let's say whether this server is reachable or not. If server is not reachable, but still the server is up. Okay, so it is not dependent only on the status of the server. It depends on the actual parameters of the server. So if it is not reachable, it means there is some issue with the server. Okay, if the application is not reachable, it is down. In that case, there is some issue with the application as well. So what is happening here? The load balancer is behaving intelligently and sending probes, sending certain conditions, sending certain commands on regular basis, and based on what is the response, based on the response, it is taking steps. If we find that the server is good, then it is good. Everything will be fine, stable. But if we find that server is not responding, in that case, what is happening? The load balancer is declaring that server as unhealthy and stopping all the incoming requests to that server unless the load balancer get the OK report for that particular server. So this is how the stability is maintained properly. Okay. So now let's discuss one of our favorite example of Netflix so that we understand this pretty much more. So when you press play button on Netflix, your request travels to Netflix servers, right? And on those servers, the Netflix service process is already running in the memory. Okay. And the process receive your request, process it, and then stream back to the video, and then stream back the video to you. So what is actually happening here? We have the application, but there is a application process which is running in the server. Okay. And this application process is responsible for any type of processing for your application. Your application is there, okay, in your mobile, but this application is managed by that application process, okay, which is there inside the active area. Remember, in our last videos, we discussed what is the active area. Playing area for the server is RAM. So that process is running inside the RAM. And whenever you do any request from your device, from your mobile, okay, the request travels here. The process handles the request and send back the response. But somehow, if something is happening or happened to this particular service, which is there in the RAM, which is running in the RAM, okay, uh, your application will also go down. Okay, so this is what I want to tell you. If the running process crashes, the machine itself may still be the powered on and reachable, but the streaming service will stop. So what is happening here? The service is crashed, which led to your application crash, but the server is running properly there. So this is what I want to share you. Okay. In that perspective, also user may feel that server is down. No, server is not down. Your application process is down or killed by the operating system for various reasons, for increased load, for increased memory usage and all and all. Okay. So various reasons are there. But if that process is down, if that process is killed, in that case, your application will also not work properly. Okay. So this is what I want to explain. So now we have understood that how load balancers are doing this health check. Okay. What will happen if the load balancer finds a particular server unhealthy? Okay. What is the process within the server? Okay. You know what is the process and what is the application, what is the relationship between this process and that application and this server. Okay. So all these things are interconnected. So I think you have this full picture clear. In our next video, we will go in deep. Okay. We will understand why the server is not responsive, or we will go deep and understand how CPU, memory, and disk or network, all these four pillars are responsible for server slowness. Okay, so this will be a new interesting chapter which we will discuss. So if you have any question with respect to load balancers, let me know. I'll try to answer it. And again, request you to join the membership for English as well as for Hindi in our Helpdesk Hindi channel, and let your ServiceNow journey boom. Thank you so much.